Okay, out. Had to do some shit. We're back. I'm not gonna do a self-test tonight. I'm gonna change my strategy up. I think I'm gonna do like recently it's been 45 minutes every day for the self-test. What if instead we do like an average of 30 minutes, but what we really do is we do an hour and a half deep dive into everything every 3 days. So like 3 hours of regular study, 3 hours of regular study, hour and a half of regular study, hour and a half self-test, exhaustive, show everything I have. Because then in 3 days, I'll be doing 7.5 hours of regular study and an hour and a half test, compared to in 3 days doing, oof, right? Isn't it 2.5 hours? Hold. Instead of doing 4.5 plus, let's see, 135. I mean, if we just do the minutes real fast. Right? If we do, oh my god. If we do 3 days and each day is, what would we do? Yeah, like, is 135 minutes of normal, and then, what is it? Is it 90? Hold, no. And then 45 minutes of self-test. So we have test, and then we have normal study. All right, and the total is 180, so 3 hours. But instead we do 180 normal, 180 normal, and then 90 normal, 90 self-test. And this should actually be 135 normal, 135 normal, 135 normal, 45, because I feel like I'm not able to get all the way into it on here. I'd rather have an exhaustive self-test. So instead, this is 135, and then what is this? 425. Hold. 390. Oh, 405. Okay. Right? 90T. Okay. Instead, it's 360 and 90, 450. 450 this guy, and then 90. And the total here is 540 still, right? Yep, 540. Okay. So the point is that in 3 days, I'll be doing less testing, but a more exhaustive test. Let's do that. So we'll say today's the first. Just straight learn. Okay. And today we're not going to hit the time, but it's okay. All right. Okay, we can use to array and pass in just the initializer, right? Are we doing to array and then to array? Well, oh, standard. Wait, hold. Just didn't even have a main function. To array. Ah, okay. And then we're passing in the initializer of the array, the address of an array. Ooh, okay. All right. So what if we said? Wait, did he just do copy initialization? Oh, he's doing auto. But I mean, we could just do const expression standard array of an int. Well, I guess you could also do that, huh? Const expression auto x, sure. And it is standard to array. And let's say we know it's integers, but we don't know what type. And we'll say and so this deduces If this returns a standard array and it's able to deduce the count, this should be identical to um, to array returned the const expression standard. Okay, so it returns a standard array. Okay. Or this is actually just saying, yeah. Yeah, it is. Okay, cool. To array is more expensive than just creating a standard array because we're creating a temporary and then copying it over. Exactly. Makes sense. Because we're initializing the values once and then another. And this makes me, well, it seems like it wouldn't be more expensive, right? If we were using move semantics, but I guess it's not. It would be cool if we didn't use copy semantics, we instead just use move semantics to move the values to be under the standard array. Excuse me, only using in cases where the type can't be effectively determined from the. Oh my god, dude, these cables are going wild. I don't know why. Where the type can't be effectively determined from the initializers, huh? Meaning just when it's hard? I don't really understand. Oh, if there's no literal for something, then we could just say to array and then have auto to actually create a standard array of a type short. That makes sense because we say to array and we say, hey, the to array is short, but we can't specify that the. Well. Oh, is it because we're gonna get narrowing? Well, wouldn't we get it either way though? Did we get? We don't even get narrowing. What's the issue here? Oh, it's because it's const expression. So, well, if we're using it in const expression context anyways, the compiler is going to check to make sure it's not narrowing anyway. So like here, oh, we actually still don't even get narrowing. Okay. I mean, it's, oh, well, it's because the literal is a literal. I'm trying to check if I still have toothpaste on my fingers. They're a little clammy still. Yeah, it's definitely a little toothpaste. Alright, it's fine. Literals are compile time values anyways, so it's able to check, hey, we're in const expression mode, yo. We're at compile time. I see that one clearly fits into a short. One is not out of bounds. We're good. Oh shit, this is the crazy good one. This goes to the most important again. This goes to 1A. This is really, really good. What is this from? What's the origin? Bravely default. Oh, fuck. That makes sense. Oh my god. Hmm. Oh, the point is, if we're trying to create a standard array of shorts, but we don't know how many shorts, we could say, hey, we know that we have shorts, and we don't care about how many, and we're using this as a to array to find out how many elements and put it into a standard array. Okay, I gotcha. Can also do subscript. Do we still get some size bullshit? Where the size is of this specific type, so we can't index it with sign types? This is fine because it's constant. It's the fucking wind, man, the fan. I killed another spider a second ago, so I'm not on edge, but I'm wary about little vibrations on me. It rained the other day, so spiders are all up in here. No bounce checking. Oh, fantastic. Okay. I mean, we probably still have .at, right? Oops. Okay, we totally can. And if these values are const expression, it is a const expression function, right? Or hold, .at. At is a const expression function, so shouldn't we be able to use this as an initializer for the size of something else? So we could say like if I wanted to, for some reason, to have an array of the little metal divots in an attachment, in a handguard attachment on a firearm, and on the gun is an array of pieces. So it has the barrel, and it has the stock, and it has the pistol grip, and it has the optics, and whatever it's got, the grip, etc. The handguard, the gas tube, the fucking buffer tube if applicable, the bolt, the fucking charging handle, the muzzle brake, any of these kind of things here. It's this big long array of all the pieces on the gun. And we could say, okay, we're going to say at this guy and use it to initialize something. We're going to say maybe the hand guards for some stupid reason are identified by how many little metal ridges they have. Well, I could then create a standard array, a const expression standard array, int your mom at 3, my mom. Boom. And this array is that attachment. So this could just be called gun, handguard. Boom. And this works because this guy is because the at member function for a standard vector is a const expression function, member function. So it can be evaluated at compile time if passed compile time values, which in this case, all of these values are const expression because the array is const expression. And this is being used in the context of a const expression. Boom, it can evaluate at compile time. But really, the point is that it's being passed a compile time value, and it's not doing anything else that's runtime only. Therefore, when we use it in a compile time context as a non-type template parameter, its return value being an integer, we're good to go. Hello? Okay, we're good. What type of initialization does standard array use? It uses... Okay, I gotta wash my hand. Bro, this toothpaste, I fucking cannot. It's been at least weeks, maybe even months since I last got actual toothpaste stuck on my hand after brushing my teeth. I mean, I always wash my hands after, but like I fuck up and miss the back. And when I'm holding it, the freaking shit drips down. Gets on the back of the hand, or at least it used to. I used to brush my teeth fucking messy, but it's better now. Excuse me. Alright. Aggregate initialization. Why do you explicitly value initialize a standard array if we're not providing an initializer? Well, because duh, broski. The standard arrays, the length and the length / capacity / size must be known at must be specified at compile time. Therefore, when you create the standard array, it's going to create that number of elements at compile time or at runtime, whatever. It's going to create that many elements. The length just needs to be specified at compile time. And when it creates those objects, if the objects aren't value initialized to be whatever the value that they get initialized with by default, well, they're going to be fucking uninitialized. And if you use them as they're uninitialized, you get undefined behavior. Just like if you said int x semicolon and then standard character output insert x, insert inline character semicolon. Boom, you get undefined behavior, bucko, and it's going to say, hey, you can't use this because you're using an uninitialized variable. And let's see what the actual error is when we get that. Standard array int int x, this guy. Oops. What if we just do hold. Oh wait, oops, hold. It's valid. So in this case, it has one element, and it is not specified what the value is. So we shouldn't increment it at all, but here it is. There it is. Excuse me. Undefined behavior, bucko. Minus 858 million. Hundreds, thousands, million. Yep. But if we say bop, good to go. You gotta value initialize that bitch. Otherwise, it has garbage value, my friend. Australia don't have wrestling. Rushing. Rushing. This English is so entertaining. Define a standard array that will hold the high temperature for each day of the year. Okay, makes sense. Sure. For each day in the year, so we could say 365, or we could have a constant expression. We could have a constant that's just days in a year, and then pass that as the type, and then pass double, or double as the type, and that as the count. Yeah. What do you think? So we could have namespace weather. Bop. Uh-oh. Hold. Oh, well, it's constant expression, so we can't change it. Hello? What's happening here? Oh, why did I make that? Oops. There it is. The first two are set. Cool. Why did I make that const expression for a second? It just needed to be const because daily temps is not const expression, so we can't initialize. Well, it's not going to be known at compile time because it changes. So it can't evaluate to a constant. Makes sense. Yeah, it's not const. The standard array would have to be const. Could we do that if it actually was? We could. Oh, wait, hold. Oh. Oh. Okay, can't do it in a for loop. Damn. We're printing E. Why? Fuck. Fuck. It needs the type. Oh, what about auto? Oh, didn't return. Dumb, 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 dumb. Fuck. Wait, could you already do it? I think maybe the deduction's going wrong. What if we just say that it has to be this type? This won't work, but what if we say it is? It actually works here now. Oh, oops. We don't, well. So, yeah, it is. The type deduction is getting wrong here. So, it's not, I guess it's not deducing this guy properly. It's thinking that this, is it decaying or is it converting this to a C-style string? And then it doesn't know if it wants to convert it to a C-style string or something else? Maybe. Something like that. Okay. But really, in this case, we just want to go. E. Standard. Oh, hold. Const expression standard array that holds characters. Print the value of the element index 1. Bop. Easy enough. Uh-oh, magic number, bucko. 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 Alright. Yeah, default. Oh, nah. Standard array length and indexing, huh? Different than normal size and stuff? It's different than the type of aggregates we normally do. Our aggregates normally do not have member functions. But array, unless it inherits from standard vector, which I don't think it does, it also just has at. Or maybe there's a base class that both inherit and standard vector inherit from. But I guess not, because standard vector doesn't get that same constructor. Because it's not, it doesn't get aggregate initialization. It uses a member initializer lift. In a constructor, I believe, because it's not an aggregate. Yep, same issues, makes sense. Yep, I'm already very, very aware of that. AI does not like to incorporate that. It always says, "Oh, be careful, bro. Even if it's const expression." No, motherfucker. If everything's const expression, the compiler will substitute those things for those objects for their literal values and see that, hey, there's no conversion error here because this type can hold this value. Example, a short can hold the value of 42 because a short is a 2-byte motherfucker. So it is some size. Isn't it twice? Isn't it in like 60,000 or something like that? Or 32,000 maybe? The length of array and type standard size T. Okay? Are we gonna say the same thing where it has a standard size type, which by default is initialized with size T unless it has a but standard vector has an iterator and apparently standard array doesn't have an iterator. So maybe it doesn't because the iterator determined whether it was getting standard size T or whether standard size type was initialized with something else. Oh, it is just a straight up size T. Okay. Oh yeah, we saw that earlier in IntelliSense as the non-type template parameter. Yepo. Wait, this busts. This slams. No body. Meaning that somehow in there is somehow inside the array in is the number of elements. I don't know how that is determined. Yep. When we define it, we don't. Gotcha. As long as it's compile time. So we could have a signed const expression integral value. And it's cool. Okay. Prior to 23, it didn't have a literal suffix for size T. It has a literal suffix for size T? Oh, because this is just integral. Well, it's not integral promotion or numeric promotion, but it's numeric conversion, so it's fine. It's safe anyways. It's widening. Type deduction, so you could put in. Oh, gotcha. You could put in 0z or 0uz. Uz is size T. Unsigned Z is the big boy. Because there's no iterator. Okay, so it does still have a nested type def of size type, which in this case is always size T. Meaning that indices aren't always supported by standard array? Always. Okay. Note that the non-type template parameter is a size t because size type is defined inside standard array. So if we're creating one, the object doesn't exist yet, so it just sees a standard size t, which it then converts to its own standard size type and initializes with that template value, or well, a non-type template value. It's a template value. It's just it's not a type. It's not a type value. It's a value. A non-type value. This language is retarded. Bjorn Straustrup. Everywhere else is size type, but specifically that non-type template parameter is standard size t. Okay. Sure, this is super relevant to my Unreal skills. So we could do size again. This is being presented as if there's a better solution. Size returns const expression, huh? Yeah. Yeah, standard size and then pass it in as an argument instead. Yep. Just like before. Or is it also going to do S size? Yeah, it is. Okay. Unlike standard string and string view, which have length and size, which do the same thing, standard array and the others just have size. Makes sense. Yeah. I mean, I could see it. A string has a length, whereas a container in general has a size. Same thing, just different syntax. And then as a large side, pointed of t, yep. Only one that returns it as assigned, cool. Getting it as a const expression value? I mean, these already yield it as a const expression value, no? Unless size and standard size are different. Okay, each does it, makes sense. Even when called on a non-const expression, because, bro, is that a fucking, okay, it's a mole. Jesus, dude, I'm just paranoid now. Because the non-type template parameter, the size of the array is known at compile time, well, we can always get it at compile time. Okay. Makes sense. Yeah, we did this earlier, kind of similarly-ish, but with a value, not with the size specifically. Meaning that we could get the size of it and initialize something else of that size. Like, what would we want to do? We could do, if you had a backpack and you had 10 items in it, so the size of the backpack is 10, you could create another thing of that size specifically. You're like, hey, I always have this big ass backpack. It can hold a lot more than this right now, but I only want the backpack to really hold this. So what we could do is create another standard array of that size. I mean, there's no point in there. It doesn't make any sense, but Because the size of it is const expression. So if I used it to initialize another one with the same size, then it would just be copying the standard array without copying the values. There'd be no point. Okay. Okay. That's it for now. More tomorrow. No more time.